Hello students, today we are going to learn a new chapter from state SSC 10th class, that is a heat chapter. So very important chapter, not only for 10th class, and these basics are very important for students who are going to pursue intermediate. Okay, in this chapter we are going to learn what is heat and units of heat, what is temperature and units of temperature, and what is thermometry, and what are the units of temperature and the thermometry, how do you measure this temperature, and thermal equilibrium. Then after, the relation between temperature and kinetic energy, and then method of mixtures. So after that we'll go to learn specific heat, derivation, definition, and specific heat of lead shots. Then after application of specific heat, then we are going to learn important concepts like evaporation, condensation, boiling point, melting point, and freezing point, humidity, fog, mist, dew. All these contents we learn in this chapter. So before going to our chapter, we will understand what is heat, why do we need to study this heat chapter, and when we use this heat and temperature, is this heat and temperature is same or different? All these contents we will go to learn now. So what is heat and what is temperature? In our generally we use this two heat and temperature words for the same thing. Suppose if it is hot, today is very hot and it is heat, very heat, and heat is more and temperature is more. Like that we relate both that heat and temperature. Is it the same? Really? No. Two things are different. Heat is different, temperature is different. Then what is heat? So heat is nothing but it's energy. We already understood and we learned in our earlier chapters. It is a form of energy. So it is an energy, and how do we define then heat? It is a form of energy to transform from one body to another body. Then which body to which body? Then high temperature body to low temperature body. It can transform from high temperature bodies to low temperature bodies. That means if there is a temperature difference, then only heat will transform. If there is no temperature difference, there will be no transfer of heat. That thing also we'll discuss at the time of thermal equilibrium. Okay, so first of all, so we will define heat. So heat is a form of energy. It is a form of energy, and it will transfer from high temperature bodies to low temperature bodies. This is the definition for heat. So we understood that. So it is energy, and it will transfer only then that there is a temperature difference. So then, what are the units of temperature? Is it a scalar quantity or a vector quantity? It is a scalar quantity. It is a scalar quantity. That's why it only have magnitude. There is no direction. It only have magnitude. That's why it is a scalar quantity. 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 Then What are the units of heat? There are two types of units we generally discuss. One is CGS unit and another one is SI unit. Nowadays everybody is using SI units only. So there are two units. One is CGS unit and SI unit. In CGS unit, what is the CGS unit for heat? Then it is calorie. C-A-L-O-R-E, calorie. Then what is the SI unit? Joule. So what is the CGS unit of heat? Calorie. And what is the SI unit of heat? Joule. Okay. Is there any relation between this calorie and this joule? Yes, there is a important relation that is important for examination point of view, also for 1 mark and 1 mark question. That is the relation between 1 calorie is equal to 4.182 joules. We can round it like 4.2 joules. 1 calorie is equal to 4.2 joules. Very, very, very important. 1 calorie for 1 mark question. So you have to remember 1 calorie is equal to 4.182 joules or 4.2 joules. Okay, so this is all about heat. So then what is temperature? So we'll understand what is temperature. So it is simple way we can define. So temperature is nothing but a measurement for heat. So how do you define this temperature? So it is a degree of hotness or coldness of a body. So what is temperature? How do we define temperature? So temperature is a degree of hotness or coolness of a body. So by using temperature we can measure the heat. So that's why temperature is a measurement for heat. So we can say like this, it is a degree of hotness or coldness of a body. If you want to find so how much heat you have given to that body by using this temperature, it's a measurement. So how do you use this measurement temperature for finding the heat? What are the units for? First of all, we'll understand what are the units for temperature. So units of temperature, again we have different units. In CGS units we have degree Celsius. We can represent like this, degree Celsius, C power 0 Celsius. Okay, degree Celsius. Another one is Fahrenheit. Fahrenheit is represented with the F. Next one is SI unit. SI unit for temperature is, we already know that. So Kelvin is the SI unit for temperature. Again, is there any relationship between degree Celsius to Kelvin, Fahrenheit to Kelvin, Kelvin to Celsius? Yes, there is a relation. Before going to know that relation, we have thermometry concept. What is thermometry? Thermo means heat, metry means measurement. So how do you measure this heat? With this thermometry, we have 3 different scales. By using 3 different temperature scales, we have 3 different temperature scales. What are they? First one is so it's named like degree Celsius scale. First one is Celsius scale. Second one is Fahrenheit scale. Third one is Kelvin scale. By using this, there are so many scales we have. Generally, we discuss for basics. We need to discuss about these three scales. What is Celsius scale? What is Fahrenheit scale? And what is Kelvin scale? In the first scale, we discuss. How do you find that Celsius scale, or how do you define that Celsius scale? For every scale, we have a starting point and an ending point. If you see a meter scale, or if you see a 15 centimeter scale, so 0 to 15. Suppose 30 centimeter scale, 0 to 30. 100 centimeter scale, 0 to 100. Like that, we have starting point and ending point. For the Celsius scale also, we have to define starting point and ending point. What is the starting point for Celsius scale and what is the ending point of Celsius scale? For finding the starting point and ending point, we consider freezing point of water is the starting point, and the boiling point of water is the ending point. So we know that what is the freezing point of water in degrees? 0 degrees centigrade. This is freezing point. That is starting point for scale, the Celsius scale. Freezing point of water. Like that, there is another one. 100 degrees centigrade is the boiling point of water. So this freezing point and boiling point, we can write it as a L lower point, and this is upper point, LP and UP. Lower fixed point, otherwise you can write it as a lower LFP, lower fixed point. This is fixed, that's right, lower fixed point. This is upper fixed point, UFP, upper fixed point. So with this, we can define the Celsius scale. So what is Celsius scale? It is a scale its lower point is lower fixed point is 0 degrees centigrade, upper fixed point is 100 degrees centigrade. So these what is the difference between this lower fixed point and upper fixed point? That is 100 degrees. This 100 degrees is divided into 100 equal points. Then what is the each point 1 degree. So like that, 0 to 15, 0, 1, 2, 3, 4, 5, 6, 7. We divided into 1, 1, 1, 1, 1 difference. Like that, here also we defined. We have taken difference of upper fixed point to lower fixed point. That is 100 degrees centigrade. Each one is 1 degree centigrade. How many parts we divided? 100 parts. So this difference is divided into 100 parts. Then each part is 1 degree. So that point we have to remember mostly. Okay. Then second one is Fahrenheit scale. So we have a formula for this. We have a formula for this. What is that? Celsius scale. That is C minus, because we are defining centigrade scale. C minus lower fixed point. Lower fixed point is 0 degree centigrade. Celsius C minus 0 divided by how many divisions we did, or what is the difference between upper fixed point and lower fixed point? That is 100. So we can write a scale like this: C minus 0 by 100. The C means Celsius scale. It represents a Celsius scale. 0 means lower fixed point. So this 100 means not boiling point. This 100 is difference of upper fixed point to lower fixed point. That is 100 degrees. So then with this we define the Celsius scale. After that, we have to define Fahrenheit scale. What is Fahrenheit scale? Again, this is also a scale. This have starting point and ending point. In this starting point, here also we take consider water. So freezing point of water in Fahrenheit is equal to 32 degrees Fahrenheit. Freezing point of water in Fahrenheit is equal to 32 degrees Fahrenheit. It is 212. What is that? 212 degrees Fahrenheit is the upper fixed point or boiling point of water. In Fahrenheit, not Celsius. Celsius means 100 degrees centigrade. In Fahrenheit, you're defining, that's why this is 212 degrees Fahrenheit. So then what is the difference? This is upper fixed point. This is lower fixed point. What is the difference? 212 minus 32. That is equal to 180. Then this scale is divided into 180 equal parts. Then what is the each part? 1 degree Fahrenheit. Each part is 1 degree Fahrenheit. Like that we divided the scale into 180 equal parts. So what is the difference here? 180 degrees Fahrenheit. 180 degrees Fahrenheit. Okay. Then how do we define this scale like this? So here again, this is Fahrenheit scale. We are going to define F minus. Here we take a lower fixed point for water. In degrees Celsius we take 0. For in Fahrenheit scale we have to consider 32 lower fixed point of water. Then what is the difference? I told you that the difference of this upper fixed point, lower fixed point. What is the difference? 212 minus that is 180. So this is equal Fahrenheit scale. For Fahrenheit scale we define formula F minus 32 by 180. So with that we define the Fahrenheit scale. Then what about the Kelvin scale? So Kelvin scale is the SI units. Kelvin is the temperature unit for temperature. SI units for temperature is kelvins. So in Kelvin scale, how do you define? Again, so we already know that how many degrees, 0 degrees is equal to how many kelvins? 0 degrees is equal to 273 kelvins. What is that? 273 kelvins. 0 degrees is equal to. Then what is the lower fixed point? Then 273 kelvins is the lower fixed point of water. So this is the freezing point of water in kelvins, 273 kelvins. Then what is the, then 100 degrees is equal to how many kelvins? 373 kelvins. Upper fixed point is 373 kelvins. What is the difference again? 373 minus 273, that is equal to 100 degrees kelvins, 100 kelvins. So then how do we find the formula for this scale? That is equal to again, so K means kelvins minus, so lower fixed point here. What is the lower fixed point here? Not 0 degrees. We are defining in the kelvins. That's why 0 degrees is 273. That's why K minus 273 divided by. What is the lower fixed? What is the difference between this upper fixed point and lower fixed point? Again, 100. With this 100, what did we understand? We understood that each Kelvin scale is divided into 100 equal parts. That is, each part is 1 degree. So these are the 3 different scales. One is Celsius scale, second one is Fahrenheit scale, third one is Kelvin scale. Then what is the relationship between these 3 scales? So relationship between these 3 scales is C minus 0 by 100 is equal to F minus 32 by 180 is equal to K minus 273 by 100. We can simplify it also. This is a 20 table. In this 3 things, 20 table is going to cancel 5 times, 9 times and 5 times. So what is that? C minus 0 means C. C by 5 is equal to F minus 32 by 9 is equal to K minus 273 by 5. This is the relationship between these 3 scales. What is that? C by 5 is equal to F minus 32 by 9 is equal to K minus 273 by 5. So this, we can relate these 2 things. Sometimes in questions also. So objective questions or in 1 mark questions. In questions also, here in examiner may give you degree Celsius. You want to convert it into Fahrenheit. Sometimes he may give you Fahrenheit and you want to convert into Kelvins. Sometimes he may give you degree Celsius and he may convert it to Kelvins. Sometimes he may give you Kelvins and you want to convert it into Celsius scales. Celsius. So whatever that question asks that, accordingly we will use this formula. So we'll do some examples for conversions. So conversions for temperatures. Okay, from Celsius to Fahrenheit, Fahrenheit to Kelvins, Kelvins to degrees Celsius, like that. So suppose if anybody gives you that, convert 38 degrees into Fahrenheit. So like we'll take Celsius, degree Celsius is equal to 38. He want what is the Fahrenheit, F. How do we convert? We use this formula, this relation. So relation is C by 5 is equal to F minus 32 by 9. C means what? How much? He has given already in the question, already given that C is equal to 38 degrees. So 38 by 5 is equal to F minus 32 by 9. This 5 is going to cancel, like 7 5s are 35. Again we have 3.36, 7.6. We can cross multiply like this. So 9 into 7.6 is equal to F minus 32. First of all, we will multiply 7.6 with 9. 9 6 are 54, 4, 5. 9 7s are 63, 63 plus 5, 68. That means 68.4. So here we take 68.4. Okay. Minus 32, if you transpose minus 35, 32 this side, that is plus 32. That is equal to Fahrenheit. We are going to convert into Fahrenheit. Actually, if we add this 32 for this, 4, 8 plus 2, 10, 6 plus 3, 9, 100, 100.4. That means, if suppose Fahrenheit scale, that is thermometer, for the better example, then thermometers will find temperature in Fahrenheit. If suppose, if thermometer shows like this, 100.4 means, so that is a fever. So we got fever like that. So that means in Celsius scales, in Celsius that is 38 degrees Celsius. If our body is in 38 degrees centigrade, that means we are suffering with fever, because it is 100.4 in Fahrenheit scale. So in the thermometer it shows 100.4, like that means 100, above 100 means it is obviously fever. So in this way we will convert from degree Celsius to Fahrenheit. Like we will convert a Fahrenheit to Kelvins also with this, by relating these two things. Like that, if we can convert Celsius scale to Kelvin scales. Like for this we can convert in this way, or directly also we can convert. How? We'll do it. Example, we'll take example. If anybody asks you that, what is the, okay, C, if centigrade, in centigrade scale it is C is equal to 100, then what is it in Kelvins? 100 degrees centigrade. What is it in Kelvins? How do you find? So directly we can take like this, C by 5 is equal to K minus 273 by 5. So if this 5 goes to cancel. C means 100, already given in the question. K minus 273. If you transpose minus 273 like this side, 100 plus 273, that is equal to Kelvin, that is equal to 373 Kelvins. Like this. We may not use this formula directly. We can do it for Celsius to Kelvin directly. 0 degrees centigrade means 273 Kelvins. Directly we can convert. Like if suppose if we given 100 degrees centigrade, that is equal to 273 plus 100, that is equal to 373 Kelvin. Directly we can convert directly with this relation. 0 degrees is equal to 273. Okay. Like this we can convert from degree Celsius to Fahrenheit, Fahrenheit to Kelvin, Kelvin to degree Celsius. So this is very, very important. Not only in your 10th class, it is useful in your intermediate also. So there is chapters for thermodynamics, thermal expansion of solids, liquids and gases. There you may encounter all these things. These basics are very, very, very important. If you are good at this point, it will be easy and helpful to in your intermediate in objective sense also. Okay, I hope you understand up to now. After this, we are going to discuss about thermal equilibrium. What is thermal equilibrium? This is also very, very important in our intermediate also. The first law of thermodynamics, we discuss about this thermal equilibrium. So first law of thermodynamics and thermal equilibrium, both the concepts are same. So here in your 10th class, there is no first law of thermodynamics. Just only what is thermal equilibrium. That thing we'll discuss. What is thermal equilibrium? The name itself tells you that what is thermal equilibrium. What do you mean by thermal? Thermal means heat. We already know that. Thermal means heat. Equilibrium means same, equal. So what is heat equal? When this heat is going to equal. So that is thermal equilibrium. If suppose by doing small activity, we'll understand easily. If you take a cup of coffee or tea, initially it is at 100 degrees centigrade. Yeah, you can use a thermometer also for finding this example. So if any measurement for this 100 degrees centigrade, and if you kept openly for some time, after some time, so it will reach us to 38 degrees or whatever the atmospheric temperature it is. If suppose the atmospheric temperature is 30 degrees, it will lose us this 100 degrees centigrade, 30 degrees centigrade. If room temperature is 30 degrees centigrade, so it loses this 100 degrees centigrade to 30 degrees centigrade. After that, if you kept for 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hours also, the temperatures will not goes down. What happened? Simple. At that position, the temperature of coffee and the room temperature or atmosphere temperature is same. That is called equilibrium, because thermal equilibrium. Here the coffee temperature is 30 degrees, heat of the temperature of the coffee is 30 degrees, atmosphere temperature is 30 degrees. Both are equal temperatures. That is called thermal equilibrium. That is, I told you already, thermal equilibrium. Thermal means heat. Equilibrium means equal. Both the temperatures reaches to same point. There is no transfer of heat. At the time of definition of heat, I told you that heat will be transformed from high temperature bodies to low temperature bodies. At the time up to 30 degrees centigrade of coffee it transforms its temperature to 30 degrees atmosphere. At that time it reaches to coffee is 30 degrees centigrade. There is no transfer of heat. This position is called thermal equilibrium. This law is called first law of thermodynamics. This first law of thermodynamics word is not helpful to in 10th class, but it will be helpful to your intermediate. This law is called thermal. This law is called first law of thermodynamics. Then, what is thermal equilibrium? How do you define thermal equilibrium? Very simple. If two or more objects are in thermal contact means both are open. Thermal contact. It is called thermal contact. Like here, I kept this coffee openly. Now this coffee and openly, I kept it open. That means this coffee and this atmosphere in thermal contact, like that. Suppose if you take a room, in that room the chair, the bed or the fan, you all are in thermal contact, because that's why all of you are maintain the same temperatures. If you consider the room, in that room, you are thermally contacted with all the things in that room. So there is the thermal contact. That means thermal contact. Here we are going to find the thermal equilibrium. If two or more objects in thermal contact, at that time, when there is no transfer of heat happens, that position is called thermal equilibrium. That law is called first law of thermodynamics. Very simple. When thermal equilibrium will attain? When the objects are in thermal contact. the stage where there is no transfer of heat between that objects. That position is called thermal equilibrium. That law is called first law of thermodynamics. So you can define like that, thermal equilibrium. When two or more objects in thermal contact, when two or more objects in thermal contact at this stage, if there is no transfer of heat, at this stage if there is no transfer of heat, that position is called as thermal equilibrium. That law is called first law of thermodynamics. That law is called first law of thermodynamics. This is the definition for thermal equilibrium. Okay, so we understood that what is thermal equilibrium. Then we have one more small thing for examination point of one mark question. What is absolute scale? What is absolute scale? Absolute scale. If the temperature is measured in kelvins or Kelvin scale, if the temperature is measured on the Kelvin scale, that scale is simply known as absolute scale. If the temperature is measured on the Kelvin scale, that scale is nothing but absolute scale. That means Kelvin scale or absolute scale, both are same. Okay, so that is absolute scale. After that, we have very important relation between very important relationship between temperature and kinetic energy. So we understood that what is temperature. Now we are going to discuss about what is kinetic energy also. First of all, before going to this relation, before going to relate to both the things, we'll understand what is kinetic energy. Kinetic energy, K. Actually, this thing already you learned in your 9th class. What is kinetic energy and what is potential energy. So again, we'll refresh here. So what is kinetic energy and what is potential energy? First of all, we'll understand what is kinetic energy. If an object possesses, kinetic energy means if it is in the motion only. That means energy possessed by a body by virtue of its motion. If any object which is in motion, it attains some energy. That energy is nothing but kinetic energy. Suppose if it is the marker, this marker is in motion, this attains some energy. That energy is nothing but kinetic energy for this marker. Okay, like that. So what is kinetic energy? Energy possessed by an object by virtue of its motion is called kinetic energy. So what is the formula for kinetic energy? Kinetic energy K is equal to half mv square, where m is called mass, v is called velocity of the object. So that means if velocity is more, kinetic energy is more. If velocity is going to less, velocity of object is going to less, kinetic energy is also going to decrease. So then, what is potential energy? PE, potential energy, is nothing but energy possessed by a body by virtue of its position. If an object is in its position or height, an object possesses any energy possessed by a body by virtue of its height is called potential energy. Potential energy P is equal to mgh, where m is called mass, g is called gravity, h is called height. Means that's why this is height. If suppose if object is at a height only, the object is at attain potential energy. What is total energy? Total energy or total mechanical energy. What is total mechanical energy? Simply it is Ke plus Be. You can call it as kinetic energy and potential energy is nothing but total mechanical energy. Another way also, internal energy also same. What is internal energy? Internal energy is equal to sum of linear kinetic energy plus rotational kinetic energy plus vibrational kinetic energy plus potential energy. So sum of all these energies is nothing but internal energy. So this internal energy concept also will utilize. Okay, and at that time I will explain it is. Okay, so we understood that kinetic energy, potential energy, total mechanical energy and internal energy. So now we are relating kinetic energy with temperature. So what happens if temperature is increased? What happens to the object's kinetic energy? For this, there is a small activity in your textbook. What is that activity? Consider two beakers. Both are filled with water. But in one beaker, if we hot water, if we take hot water, this is cold water. In one beaker we'll consider hot water, in another beaker we'll consider cold water. In both the beakers, if you sprinkle some food colors, red color, blue color, pink colors, like that, food colors, if you sprinkle in this hot water and cold water, in which water coloring in which beaker is colored fast? Obviously we know that hot water. Why it is in hot water? Why it is not in cold water? Because hot water already attains some energy. What is that energy? Heat energy. That water molecules attain that heat energy, whatever the heat we are given to that water, and that's why it becomes hot water. So that water molecules attain that heat energy. That's why they got energy. If we get energy, what will happen? What we'll do? We'll do things speed, okay, or we will be excited. In the same manner, water molecules also excited and they move fast. What is that? Move fast means what? Their velocity is also, water molecules velocity, water particles velocity also increases. I already told you that if velocity of the particle increases, what happens? Kinetic energy increases. That's why if you give more heat, it will extend. If you extend this experiment, if you give more heat to this hot water, this coloring of particles also more, because the particles moving very fast like that, because they are getting more heat energy from down. So in the cold water it takes more time, because there is no heat energy. That's why they color, but it takes time, because the kinetic energy is less for this cold water compared to hot water. With this, we'll understand that kinetic energy is directly proportional to temperature, or temperature is directly proportional to average kinetic energy of particles. Temperature is directly proportional to average kinetic energy of the particles. Okay, so this is what temperature and kinetic energy relation. After this, we are going to discuss specific heat. What is specific heat? Derivation for specific heat. So what is specific heat we will define later before doing this activity. With this activity we will come to get one formula for heat, and with that we can also define specific heat, formula for specific heat. So first consider two beakers, one beaker with 250 grams of water, another beaker, consider another beaker with 1 kg of water. So this mass is less and this mass is more. Like this we have considered two beakers. Both the beakers heated, we want to get 60 degrees temperature. Then which beaker will reach more than 60 degrees temperature? Less than obviously 250 grams. With this we'll understand mass is directly proportional to temperature. What is that? Or heat is directly proportional to mass. If suppose for this beaker have more mass, that's why we have to give more heat to attain the constant temperature, 60 degrees temperature, constant. Temperature is constant. For getting this more mass, Q is directly proportional to mass when temperature is constant. So change in temperature is constant. Change in temperature 60 degrees is the same. Like for that we'll write in the word from Q means heat is directly proportional to mass when changing temperature, temperature is constant. Because temperature is constant, you consider this experiment. This is 250 grams and this is 1 kg, 1000 grams. So 1 kg have to give more temperature, more heat to reach the 60 degrees temperature. For this, this is 250 grams only. It required less heat. That means Q is directly proportional to mass when temperature is constant. Like in the another experiment, if mass is constant, that means both the beakers having the same mass. If both the beakers having the same mass, that means if suppose it is 250 grams and this is 250 grams. So if we consider like this, so if suppose both these are having the same mass, so mass is constant, so then change in temperature directly proportional. If suppose if you give more heat, more temperature will get, more temperature difference. So less heat will get when temperature difference is more, increases. That means Q is directly proportional to change in temperature. That means when it is mass is constant, mass is constant. If mass is constant, heat is directly proportional to the change in temperature. Whatever the heat you are giving to that object, it will increase the change in temperature. So this, if you consider this is one first equation, this is the second equation. From these two equations we can consider Q is directly proportional to m delta T. Q is directly proportional to m delta T. Then, so if I remove this proportional and if I want to include is equal to Q is equal to I have must and should leave and a constant. That constant is S m delta T. So we already know that Q means heat, m means mass, and delta T means change in temperature. But what about the S? This S is called proportionality constant. Proportionality constant. That is also called as specific heat. So S is equal to, we can define specific heat. So then if you subjected this S as a subject, what is the formula for specific heat? S is equal to Q by m delta T. S is equal to, S means specific heat, is equal to Q by m delta T, where Q means heat, M means mass, delta T means temperature. Now we are going to writing units. So we already know that if you understand the formula, or if you know the formula, we can easily write the units for that units for that subject. That means here subject is a specific heat, so we can easily write the units for this. So what are the units? So what are the units for heat? Q, SI. First of all, we will write CGS units. CGS units for specific heat. So CGS units of Q, that we already know that calorie, cal divided by. What are the CGS units for mass? Grams. What are the change in temperature? Degrees Celsius. Degrees Celsius. This we can write it as cal per gram degree Celsius. Cal per gram degree Celsius. Then what are the SI units? SI units for specific heat is equal to SI units for Q, heat. We already knew that. We discussed all this already. That is what is that? Joules divided by. What are the SI units for mass? kg. What is SI units for change in temperature? Kelvin. This we can write as joules per kg kelvins, or joules kg power minus 1 k power minus 1. In this way we can write the units for specific heat. So now we understand what is a heat, formula for heat. So what is the formula for heat? Q is equal to ms delta T. We can write it like this also. Q is equal to ms delta T. Then what is the formula for specific heat? S is equal to Q by m delta T. So these two formulas very important for our objects, for our examination point of view and problematic problems. Okay, there you will use these formulas. Q formula, Q is equal to ms delta T. Then S is equal to Q by m delta T. Both these are very important. So now we are going to writing defining the specific heat. So what is the definition for specific heat? We understood that formula for specific heat, units for specific heat. Now we are going to defining definition for specific heat. What is the definition for specific heat? So S is equal to, what is the formula for S? S is equal to Q by m delta T. This is the formula. Okay. Now we are going to defining specific heat. So in this specific heat definition, what is the specific heat definition? This specific heat is same for all the objects. So that things we'll discuss right now. So what is the specific heat? Very simple. The amount of heat energy required, please follow me. The amount of heat energy required for 1 unit of mass of the object. What is that? 1 unit of mass of the object to rise the temperature for 1 degree centigrade. What is that? If you consider an object of mass 1 gram or 1 kg, accordingly 1 unit mass, this is called 1 unit mass. So for that 1 unit of mass of the object, you have to raise that 1 unit of mass of object to 1 degree centigrade. When the temperature rises, whenever you give in the heat, that heat is called specific heat. What is that? The amount of heat required for 1 unit mass of the object to rise 1 degree centigrade is called specific heat. Very simple definition. Don't confuse. If you understand this concept, you will be thorough with this chapter. So what is that?